Hey everyone, and welcome to This Explainer. Today, we are unlocking the black box of a technology that is, quite literally, reshaping our entire world. I mean, we hear the buzzword everywhere, right? But today we're actually going to break down what it really is. Deep learning.
So, in the next few minutes, you're going to discover the fundamental tech behind things you probably use today. I'm talking about what powers ChatGPT, how your phone flawlessly unlocks with just your face, and how self-driving cars actually see the road. We're going to break down exactly what this tech is, how it closely mimics the human brain, which is absolutely wild, by the way, and why it's the driving force behind today's biggest AI breakthroughs. Let's dive in.
All right, Section 1, the AI Big Picture.
To really wrap our heads around what deep learning is, it helps to look at the overall hierarchy. Think of artificial intelligence, or AI, as the big, broad dream of making machines smart. It's like the entire universe of smart technology. Inside that universe, we have machine learning, or ML. This is where computers learn from vast amounts of data instead of just following strict, rigid code written by a programmer. You can think of machine learning as the engine. Now, nested right inside machine learning is our main topic, deep learning, or DL. This is a hyper-advanced, highly specialized technique. So if machine learning is the engine, deep learning is the turbocharger that makes the whole thing run at absolutely incredible speeds and complexity. Moving right along to Section 2, how deep learning works.
So what actually makes this turbocharger tick? Well, computer scientists basically borrowed directly from human biology. You see, traditional algorithms seriously struggle with messy, unstructured data. Things like photos, audio clips, or handwritten text. Deep learning solves this by literally mimicking the human brain. Looking at the left side, we've got a biological neuron with its dendrites and axons, and right next to it, on the right, is its digital counterpart, an artificial neuron. Just like your brain uses synapses to pass electrical signals around, the artificial neuron receives inputs, applies a bit of math using things called weights and biases, and then passes the result along. It's kind of crazy, but it's quite literally a software version of our own neural structure.
Now, when you link all these artificial neurons together, you get what's called an artificial neural network, or ANN. We're talking dozens, thousands, or even millions of these nodes all interconnected. And it's this massive web that allows the network to learn and adapt from huge piles of data. It automatically tweaks those mathematical weights through a really clever iterative process called backpropagation. Basically, the network makes a guess, calculates its error, passes that error backward through the whole system, and tweaks the connections to minimize mistakes. It does this over and over until it gets incredibly accurate at recognizing patterns. The really crucial point here is how the data actually flows through this structure. Every neural network has a distinct architecture, usually broken down into 3 steps. First, it starts with the input layer. This is where your raw data enters the system, like, say, the individual pixels of a photograph of a dog. Then the data passes through the hidden layers, which process the features step by step. And finally, we hit the output layer, which spits out the final verdict, like predicting, hey, there's a 98% chance this photo is a golden retriever. Let's actually zoom in on those hidden layers for a second, because they are literally the deep part of deep learning. Why is this so important? Well, unlike traditional coding where a human programmer has to explicitly write out rules like, hey computer, look for pointy ears, these hidden layers figure it out completely automatically. Imagine passing an image through these layers. Layer 1 might just detect really simple lines and edges. Then, Layer 2 combines those edges to recognize distinct shapes, maybe an ear or a nose. By the time you get to Layer 3 or 4, it's combining all those shapes to recognize an entire complex face. It learns all these hierarchical representations entirely on its own. No way, right? Which brings us to Section 3, why deep learning exploded. Now, you might be wondering, if the math for these neural networks was conceptualized decades ago, why are they only taking over the world right now? Well, let's take a quick look at the timeline. The very first mathematical model of an artificial neuron was actually proposed by Warren McCulloch and Walter Pitts way back in 1943. And an early neural net called the perceptron arrived in 1958. But after that, things kind of stalled out in what researchers call an AI winter. Those early models simply lacked the computational juice to succeed. So it was a long, quiet wait until the 2010s, when we suddenly saw this staggering explosion in deep learning capability. So what changed? Well, 2 massive catalysts flipped the script entirely. First up, massive data sets, or big data.
The explosion of the internet gave us billions of images, text files, and videos. This finally gave neural networks the enormous amount of training examples they desperately needed to learn anything useful. Second, modern hardware. It turns out that graphics processing units, or GPUs, those computer chips originally designed to render 3D video games, are absolutely perfect for crunching the billions of parallel math calculations that neural networks require. So, the big data fueled the engine, and the gaming GPUs provided the massive horsepower.
All right, Section 4, Real-World Applications. So we've got the engine, the fuel, and the turbocharger. Let's look at how this incredibly powerful math is actively changing our daily lives. Because deep learning isn't just some theoretical math happening in a dusty server room somewhere. It's powering tools you probably rely on every single day. Through computer vision, it's powering autopilots in cars and allowing doctors to diagnose diseases from medical scans with mind-blowing accuracy. Through natural language processing, it's the actual brain behind your smart assistants, real-time voice translation, and chatbots like ChatGPT. And through generative AI, it's creating entirely new images, music, and text from just simple human prompts. All of this magic is fundamentally powered by those layered artificial networks we just talked about.
And finally, Section 5, Conclusion and Call to Action. We have definitely covered a lot of ground today, from the basic biology of the brain all the way to the massive GPU data centers training the next generation of AI. Look, at its core, deep learning is simply pattern recognition scaled up. It works through layered neural networks, it's trained on massive data, and it's powered by highly specialized hardware. It is, for sure, the true engine behind the modern AI revolution, and understanding it gives you a massive lens into the future of tech itself. So I'm going to leave you with this thought. Knowing how incredibly fast this tech is evolving, what industry do you think deep learning will completely disrupt next? Let me know your thoughts down in the comments. And hey, if this explainer helped clear things up for you, please engage with the content. Subscribe for more bite-sized tech breakdowns, and let us know what AI topic we should cover next. Keep learning, and I'll see you next time.